Hey, fellow mathers! Before we get into this episode, we want to share with you how you can get access to free content, professional learning that will keep your students engaged and doing the math that matters. Get ready to go to this link, mathisfigureoutable.com/challenge.
That's right. Registration is open for the free Math is Figureoutable Challenge that's starting May 15th and runs to the 17th at 7 p.m. Central. We're going to have 3 nights jam packed with learning and routines that you can take straight to your classroom.
In these challenges, we have a great time. We do some math, talk about classroom experiences, give away super cool bonuses and prizes. You won't just walk away with routines that are naturally engaging and encourage your students to think mathematically. You'll also have a chance to win over 6K worth in prizes, including a few virtual PD sessions for your school. I'll be joined by my wonderful co-host Kim and special guest Jenna Labe.
You can register at mathisfigureoutable.com/challenge for a fantastic learning experience. That's mathisfigureoutable.com/challenge. Now on to the show.
Hey, fellow mathematicians! Welcome to the podcast where math is figure-outable. I'm Pam.
And I'm Kim.
And we make the case that mathematizing is not about mimicking steps or memorizing facts, but it's about thinking and reasoning and about creating and using mental relationships. We take the strong stance that not only are algorithms not particularly helpful in teaching, but that mimicking algorithms actually keeps students from being the mathematicians they can be. We answer the question, if not algorithms and step-by-step procedures, then what?
In the last episode, we talked about how pouring algorithms into kids' heads and then having them use them is not mentoring mathematicians. It's not really helpful in teaching math. But Pam, teachers are required by standards to teach algorithms. So,
okay, never mind. So
Yeah.
if you're in a place where your standards say students will use strategies and algorithms to solve multiplication problems, okay, then I cry uncle, go ahead. I'm kidding. No. So how do we make sense of that? Like, am I telling you to just, forget your standards, ignore them? Your kids are going to bomb your high stakes tests. Is that what we're suggesting? And I think this is so important that we're going to dial down on this today. So we're going to really attack if your standards call for a formula, a step-by-step procedure, an algorithm, and you're thinking to yourself, well, then I can't do the thing. Like I'm going to have to do that. And I'll do that with other areas of math. Pam, that'll be fun. We'll make other areas fun. It's not about fun. It's about real math, what mathematicians actually do. So what does that mean? Well, here's the way we attack it. If you were to have looked in Kim's 3rd grade, 4th grade, 5th grade math class, you would have seen all year long working on helping students make mental connections, increase their sophistication of relationships, learn strategies that are based on all those relationships, and kids getting more and more sophisticated by solving more and more sophisticated, more difficult problems, by looking at all of the different ins and outs, by comparing strategies, kids getting more and more confident, learning intuition that when they see a problem, they're like, oh, like based on those numbers, that structure, I'm using that strategy. Where another student might go, well, actually, how about this strategy? And they're, oh, wow, you're right. That one's so much. Wow. And it's this conversation and learning and growing about which strategy to use when, because of which relationships are inherent in the problem, which things are pinging for kids on a certain day at a certain time, and how we can use that to make sense and figure out problems. And y'all, pick a grade. Let's pick 4th grade. All year long, Kim is doing that with addition and subtraction of harder numbers than they did in 3rd grade. Multiplication, really, because 3rd grade starts it, but 4th grade is really where you dive into it. And so Kim's spending a lot of time in 4th grade really developing multiplication and multiplicative reasoners and kids that can think about not just naked number problems, but problems in context. At the same time, she's really developing area and what it means to have length and width and how that creates this square unit of measure, which is so weird for kids because they've finally gotten used to, okay, I'm going to measure this linear thing, this kind of like meters and feet and inches and centimeters, this miles and kilometers, this linear measurement. Now you want me to measure it Like in squares? What? Like how do you felt this, listeners, when you've ever ordered carpet or tile, when all of a sudden they're giving you these crazy measurements, and then they're talking about how, well, we'd have to make a seam here, and like if you don't understand area, I'll have fun with that, because it's a different sort of measurement to have this kind of square unit. And then if you've ever ordered topsoil or any kind of, like, if you've ever landscaped and you're ordering, I don't know, mulch or whatever, and they're going to sell you a yard. Now that's in the States. I probably should have looked up what it would be in metric. But if they bring you like this measurement of topsoil or some sort of cubic measurement, I will never forget. I was like, 3 yards. We're going to need more than that. Like, we have a whole space to fill. And the guy looked at me. He's like, what's your space dimensions? And treated me like I was a ding dong. Because in that moment, I was acting like one, because I didn't have this sense of what it meant to have this volume, this 3-dimensional measurement. So in 4th grade, Kim's really building this sense of a square unit of measurement by really, really dealing with area. 5th grade, she's going to do volume, at least for our standards. All year long, that kind of stuff is happening. Then kids are going to take the stupid high stakes test. Now you know how I feel about the test. They're going to take it and they're going to do really well, because her students have been thinking and reasoning and figuring, hitting new situations over and over again, used to that when they get a story problem or word problem they've never seen. All right, we dig in. We've been doing all year. We just dig in and we figure it out. It's not reaching in rote memory. Okay, is it that formula? Is it the one we did on Tuesday? Maybe it's the one we did on Wednesday. And the teacher's like, no, it's Thursday, for heaven's sakes. It's the formula for Thursday. None of that, not that thing. Kids have been reasoning all year long. So now when they hit that high stakes test, Kim's students are going to dive in and they're going to think and reason. They're going to use their most sophisticated strategy that they've developed, because that's what they do every time they solve problems. And nothing's going to surprise them, because they're constantly in this place of just trying new things and learning to struggle productively and working to use what they know. Like they are so clear. It's about using what they know. Test goes by, kids do great. Kim has not only the sort of passing standard. Kim, I know she's hating that I'm doing this right now, but it's true that her passing standard was like near perfect. Like all of her kids passed, and then the whatever that score is, that means these are the kids that are scoring better than just the passing score. So whether it's commended or whatever you call it in your state, she has the best scores of that. Like, so many of her kids are doing so much better than just that passing standard. And so the test is over. Kids aren't freaked. Kids aren't stressed. Kids aren't like, it's not this big panic. Now she works hard to help them not ingest that panic from all the other classrooms around the school, because everybody else is freaking out. But she's like, nope, we're good. We'll just do our thing. Test passes. It's the last week of school. And Kim's like, hey guys, we got a new strategy for you. Check this out. And then, not as a series of things to do, I might say this 4 times, but as a study in why it works, Kim will put up an algorithm. So say it's 4th grade. She'll say, hey, have you ever seen anybody do this? She'll write down 47 times 99. And she'll line them up, and she'll put the little X in the line. And then she'll go, sometimes people have learned to do this. You might have seen your parents do this, maybe your older siblings, where they'll take this number over here and they'll multiply it by that number. So like, I don't know, what did I just say? 47 times 99. So they'll take that 7 times the 9, and we know that's 63. And so they'll write down just the 3 here, and they'll put that 6 up here. Weird, right? Anybody have any ideas why they would do that? And the kids will kind of fuss and whatever, and they may or may not come up with anything brilliant at that moment. I mean, they're like, well, we see the 63. There's the 3. A little weird they put the 60 over there. That's kind of weird. And then Kim might not spend too much time there because they need a little bit more to kind of see what's going on. And then she'll sort of do the next step. She's not saying, now students all do this next step. No. She's saying, somebody might do this. And so I just had to write it down because I can't keep track of the algorithm in my head. What did I say? 47 times 99? Yep. And so now they're going to think 9 times 4, right? And so she'll say, now they'll say 9 times 4, and then they'll get 36, and they'll add 6 to that. So 9 times 4 is 36, and they'll add 6 to that, it's 42. And then they'll just write that 42 down next to the 3. Whoa, that's weird. Y'all, what are they doing? Does that work? Why does that work? Draw an array. Find those pieces that just happened. Like, can you find something that is 423? Can you find like some chunks of area that would add to 423? What's that? Why? What is that 6 when they just do the 9 times 4? And then the kids, because they have great place value, because they have been developing place value all year long, look at that and go, oh, it's like they're sort of doing 9 times 4 to help them get 9 times 40, but they know they've got that extra 60 hang along, but they're doing 9 times 4 and adding the 6. Wow, that is like 9 times 40 and adding 60. But wow, the meaning is kind of hidden behind that. I mean, that's really cool. Oh, I wonder who figured that out. Okay. And then Kim will show like the next step. And the kids, because they have great place value, will be able to figure out why it works and how it works. And by the end of sort of showing some steps, the kids will say something like, whoa, that is interesting. Like all of those, I mean, okay, like there's all the meaning is kind of behind the scenes, and it's kind of hard to like feel the place value. Like somebody had to be really brilliant to figure that out. But are you saying people actually do that every time? Like for that problem, would it just be easier to find 147s and subtract a 47? I mean, that's a lot of steps with all that meaning that's kind of hidden and all the different. Wow, that's really like, why would anybody do that if they could just think about it? Now, you might be like, listeners right now, you might be like, Pam, really? Her kid said that? Well, I'll tell you what, really? My kids said that. My personal kids that had Kim as a teacher literally would look at an algorithm after seeing some steps, and they would literally be like, whoa, that is really intense. All that meaning sort of shoved behind the scenes. You can't really tell what's going on. I mean, I guess you could do that, but why would you if you can just think about it? Why would you stuff your memory full of all of that stuff to rote memorize? Why not just think about the numbers? Just use what you know to solve the problems. Mm-hmm. Okay. And then they would just move on. And it doesn't bother them because at that point they're such good thinkers that it's just one more sort of thing to make sense of and then kind of move on. And it doesn't become this crutch, and it doesn't become this sort of thing that takes over their life. Now, listeners, you might be like, well, Pam, if that's true, I'll just show them the algorithm way earlier in the year, and then they'll just have the same reaction. Oh. Do Kim and I hang out or what? So the earlier you show them the algorithm, the more you run the risk that they say, oh, I can just turn off my brain here. Mm-hmm. Like thinking's hard. Thinking is hard. Like thinking takes effort. Building your brain to think more and more sophisticatedly takes some struggle and some sense making. And that takes effort and takes like you have to work at it and some sweat. And if they see the algorithm too early and it becomes sort of a quick scapegoat, then you run the risk that they then just do that, especially if you haven't quite got the knack yet of making it not about answer getting and making it about thinking and reasoning in your class, which we're going to talk about answer getting in an upcoming episode soon. So make sure you pay attention, tune into that one. But if you do it too soon, you run the risk that it just becomes this thing to do and kids stop thinking. And that's not what we want in math class. Right. That's not our goal.
Yeah.
So you might be, let's see if we can recap just a little bit. Teach thinking and reasoning all year long. Get kids really developing their brains so that they can look at any problem and go, oh yeah, I got something. I have relationships I can use to solve that. Yeah, no problem. Then I'm totally okay that you're going to meet your standards by putting that algorithm in front of them, dissecting it, studying it. They're going to understand it far better than anybody who's ever just doing the steps.
Yep.
You have now met the standard. You've got kids that are doing great on your high stakes tests because they're thinking and reasoning, and everybody wins. We have kids that are mathematizing. We have teachers that feel satisfied and fulfilled because good stuff is happening in their class. Kids are I was about to say happy to be there. We want them happy to be there because of the relationship they have with you, but also like satisfied to be there. It's a satisfying thing to really use what you know to think and reason. Mm-hmm. And what did I miss? In that list I just did. We've met your standards. We've got good scores. Kids are happy. Teachers are fulfilled. Bam! Yeah. We're there. There you go.
That's a good place to be.
That's a good place to be.
And, I think one thing that you left out while you were talking was that teachers spend quite a bit of time showing the steps of an algorithm and then having kids practice them over and over. And then sometimes say to us,
reteach.
I don't have time to focus on these alternate strategies and like relationships and stuff. So one of the things that you and I've come back to several times is that this idea that if you can remove that time where you're practicing and teaching and over again the steps of the algorithm and replace that with the thinking and reasoning, then when you get to that last week or two and you're exploring the algorithm, then kids really do go, oh, that makes sense. Okay, well, I'm going to use it or not, but it makes sense. But you've given them all the time they need in your year to make sense of something that actually matters.
Absolutely. And another place you're going to save time, you taught me this, Kim. Everybody in, this was so new to me. Everybody in my kid's school, what, a month? And then it was like 2 months. And then it was like, I mean, the time just
Oh,
kept
yeah.
growing before the stupid high stakes test. Everyone would stop teaching. They're like, oh no, we have to get everything taught by February because then we're going to review until the test. And I'm like, what? Like, no,
That's
that's
pressure.
terrible. Let's
Yeah.
just keep building all year long until the test. Like if you feel like you have to do this huge review, maybe would you consider that that is a symptom of sort of not teaching real math? It's a symptom of that there's you're treating math like a bunch of things to memorize. And so we better go
Yep.
over and over and over and over it again because that's what you have to do for things that are rote memorized. But if you're just continue to build sophistication, then we can use that time to continue to build sophistication. Sorry, what were you going to say?
And well, I was going to say, we're not saying that there aren't things that you don't want to review or circle back to, right?
There are
We're not
some,
saying that.
yes,
There are some things.
but not the steps of the multiplication
Yeah,
algorithm.
yeah. So you have mentioned state tests a few times. And
Mm-hmm.
I want to speak to I can hear teachers saying,
Hey,
but you don't know
before
my
we go there, I think I know where you're going to go. Sorry.
yeah, yeah.
So briefly, can we mention some things that you might want to review? Like
Okay.
vocabulary, or is
Yes.
that where you were going? Were you going
No.
there?
Go
Okay.
ahead.
So vocabulary,
Mhm.
that's a rote memorized thing. That's a social conventional thing. We're
Mhm.
going to memorize vocabulary.
Mhm.
Notation might be a
Mhm.
thing.
Mhm.
Hey guys, on the test, you might see a division problem that looks like this.
Mhm.
Remember, we've done that. You might see I mean, help me. Let me get to other grade levels because I've been really focusing on fourth grade. You might see a proportion set up like this. You
Yeah.
might see the equation of a line written like this.
Yep.
You might see a quadratic equation written like this, like notation. Like now, you should have been like dealing with that notation, but maybe you dealt with one more than another. That's a good moment, actually, when you're looking at your high stakes test. That's a decent purpose for a high stakes test. It's to remind you of things that you might have de-emphasized. Oh, that's right. They should see this division symbol. They should see that form of the equation of a line. They should. See, oh, okay. Next year we'll do more to actually develop that and keep it in our repertoire as we go. But especially vocabulary is a thing you're going to review. Okay, sorry, Kim. I hope you didn't
No
remember.
problem. No
Didn't
problem.
forget where you're going.
That's okay. Well, so I'm the teacher right now listening saying, you don't know my state test. These algorithms that you
Mm,
just said teach whatever show in the last week or two,
mhm.
they're on my state test. And so I am required and
Right.
want to be responsible as a teacher in helping my kids make sense of them because they're tested on them.
Yeah, and so I let me honor the fact that you want your students to do well. You don't want anybody to get to a test and be shocked. Oh my gosh, I've never seen this. I don't know how to do that. I feel terrible now. Your teachers, you have a teacher heart. Of course, you want your students to do well and feel good about what they're doing. And so, if you're right now thinking, but Pam, you haven't seen my state test, my state test, the high stakes test that my students. So we're saying state, but we have listeners around the world. If you have a high stakes test, a test that students have to take at some point that matters for them to move on, that high stakes test asks questions that demand that students perform the steps of an algorithm, then I can totally see why you're bothered right now. I can totally, like, you are like, but I have to get the kids ready for those questions. I just took a deep breath. May I invite you to relook at any items you've ever seen released from your high stakes test and ask yourself, do your students really need to be able to mimic the steps of an algorithm in order to pass that item? If you can find an item like that, please send it to me. I have offered this around the world. Please send me an item that your students have to, that like, if they don't show their steps, if the steps they show aren't correct, or they don't find the error correctly or whatever, that you're saying to me, kids must have drilled the algorithm, have learned it, and like own it enough that they'll be able to pass this item. Please send me those items. So I've had several people take me up on that, and they have sent me items. And to this day, and I've looked at many state tests. I have looked at item after item. I've looked at the major test writers and their items. I've looked at countries tests and items in countries tests. I have yet today to find one that's true. Now you might be like, Pam, I've seen it. Okay. And I've gotten some items, but every time I get an item that actually tests the steps of an algorithm, those items have not been on a high stakes test. They've been in a test prep material. In other words, some company has said, hey, we'll help your students get ready for the test. Here's our test prep material. Use these questions and your kids will do great. And that's where they're guessing about how a standard will be tested. And their guess is showing the steps that you have to fill in. It's the guesses in a textbook, in test prep material, that are making kids fill in steps or making kids sort of have the algorithm steps rote memorized and they're able to spit them back out. That's where I'm finding those items, not actually on the high stakes tests. So if you find one, I'd love to see it. And boy, then we'll put some pressure on the writers of that test to say, not a good item. If you happen to find one, I'm almost going to, I feel very confident in guaranteeing you might find one. You're just not getting, like, the preponderance of that test, most of the test is not going to be that. Maybe there might be one. And how much time are you spending on drilling those algorithms? Like, even if there's one, which I'm not going to even grant you there is, but even if there's one item on a high stakes test that demands that kids know an algorithm, it's one item out of the entire test. Again, I'm not granting it's there, but even if there was, it's one. And consider how that weighs up against all of the time that you're spending sort of drilling those things. I'm looking at the time. Some other time asked me about a colleague in a different country that showed me I'm going to say it right now, showed me the scoring rubric that students are graded on in that high stakes test to say, look, they have to do the right steps or they don't get credit. But when we actually sat down and looked at the scoring rubric, even she smiled and said, oh, oops, missed the line that said, so students will show something or correct mathematical relationships. Like, as long as what the student did was correct mathematically, they got credit for the steps. For like, in other words, there were marks for showing how they got to the answer, and it said sort of do the traditional thing or the whatever they show is mathematically correct. The students got marks. So our point is, whether it's demanded in your standards, it's going to show up on your test, which we don't think it will. You can teach algorithms the way that Kim did. You can meet your standard by exactly what we've just said. I'm not going to repeat it all. What we said in this episode, you can get there that way and get your kids thinking and reasoning and confident and being able to do all the other things because you've spent your time doing that and not just prepping for kids to be able to mimic algorithms.
So in summary,
please.
Teachers, we're saying relationships over algorithms. Yes?
Nice.
And we're going to argue that you spend the time that you have building thinking over practicing procedures.
Bam! Nicely said. I knew I liked you. So, if you want to learn more mathematics and refine your math teaching so that you and students are mathematizing more and more, then join the Math is Figureoutable movement and help us spread the word that math is figureoutable. Thank you for listening and making math more figureoutable.
To learn even more, make sure you register for our free challenge at mathisfigureoutable.com/challenge. You are not going to want to miss the evenings of May 15th through 17th, starting at 7 p.m. Central.
Math teaching, go register now. That's mathisfigureoutable.com/challenge. Join us to make math more and more figureoutable. And if you can't join live, register and we'll send you access to the recordings. We'll see you there.